Here's a quick video to highlight some of the problems and classic aspects of an optimization problem with the calculus. The biggest issue most students have is just setting it up, so we'll talk through that. But all the work's currently on the screen too if you want to just pause it and take a look. First off, the problem, we've got a hotel owner who notes that of her 200 rooms, all are full when offered for $50 per night. And for each $10 increment increase in price, she gets a 10% decrease in occupancy. The question is, what price per night should be charged in order to maximize the revenue? So first off, on the left side here, we've just got a statement of the pattern that's happening. $60 is 90% occupancy, $70 a night, 80% occupancy. And again, for every $10 increase in price, we get a 10% decrease in occupancy. That's 20 rooms. 10% decrease is 20 rooms. So the key here is we're assuming that this pattern will continue for as long as necessary. First step with any optimization problem is to come up with a function for that which we want to optimize. In this case, we want to optimize the revenue. So revenue, quite simply, for this hotel chain is going to be cost per night times the number of rooms filled, number of rooms paying that cost per night. Next step is come up with a variable for what can change, and in this case, the variable that's changing is the price per night. The hotel owner is changing the price per night. That's the independent variable, and what seems to be changing with it, the dependent variable, is the occupancy level. Now, coming up with the function for the revenue can be a little bit trickier. In this case, and this is always helpful, cost per night was listed already as one of the two factors to find revenue. So if we let one of those two factors be our X, our independent variable, that makes our statement a lot easier. So in this case, we've already got X denoted because we called that variable this factor. Now the factor for number of rooms filled. Well, we're going to start with the 200 rooms, and we're going to take away something based on the cost per night. So quite simply, we're starting with a full occupancy, and we want to take something away. Now, in thinking through this, the first thing to think about is we want, at $50 per night, we want to take away, we want this portion here to be zero. We want to take away nothing at $50 per night because all the rooms are full. So we know we need an X minus 50 in there, so that when X equals 50, this goes away. The next step is what's our multiplier going to be, and that's 2 in this case. It's a $10 increase, and back down in the lower left here, for a $10 increase, we see a 20 room decrease. So when we get X equals $60, this quantity will be 10, so 2 times 10 is 20. When X equals $70, this quantity will be 20, so 2 times 20 is 40, so we'll have 160 rooms occupied. So if we can think through that, this statement here, coming up with R of X, tends to be far and away the most difficult part for students. Once you've got something, and periodically as you're coming up with it, it's helpful to go ahead and check to make sure you're on the right track. So in this case, we've plugged in the two X values that we know and figured out what R is going to give us. We really don't care what the revenue itself is. We just care that we have 60 and 180 per night, 70 and 160 per night. Finally, down here, the blue box, we've got just a restatement of our revenue, simplifying it. So the simplified function is 300x minus 2x squared. And the next step, after we have a function, is to come up with a domain for that function. So the space on which it makes sense, and 50, a value of 50 for x, is the smallest value per night, because we're trying to maximize revenue. We don't want to fill less than 50 rooms. We know charge less than $50. We know at $50 we've got full occupancy, so why go lower than that? So X has to be greater than 50. 50 can be achieved because at X equals 50, we'll have 200 rooms. Maximum value for X is 150. That's the maximum value because there's no rooms filled. If we charge 150, that's taking away all the rooms according to this relationship, and thus our revenue would be 0. So lastly, we take the derivative, r prime of x, 300 minus 4x, set it equal to 0, and find that x equals 75 is the point at which the derivative equals 0. Lastly, this is our critical point. Lastly, we plug in all critical points and endpoints. We've got two endpoints, 50 and 150, both of which should make sense, 150 being $0 because we have 0 rooms filled. So we plug in all endpoints and all critical points and determine quite simply which one's larger. Revenue at $75 per night is the largest of these three revenues. So our answer to give the hotel owner is she should charge $75 per night in order to maximize revenue. If you have any questions, please let me know.